Okay, now as an example, let's actually consider a real problem. So suppose that a rock is thrown upward with an initial velocity of 19.6 meters per second, which may seem a little arbitrary for the moment, but you'll see that in a very short while it'll make a lot of sense why I chose that number. And we want to find what the total time of flight is and what the maximum height is. And so, once again, the very first thing we should do, draw a picture and label some things. Okay, so we're going to label our initial velocity as 19.6 meters per second. We know that the velocity at the peak is 0, and we also know that our acceleration is equal to negative g, or negative 9.8. And I'm going to take 9.80. We could take 9.81 as a little bit more precise, but I just need 3 significant digits here. Let me make that a little bit bigger. Okay, negative 9.80 meters per second squared. Now, for the total time, we already derived that the total time of flight is equal to 2 VI over G. Okay, and so if I plug these in, okay, if I actually plug these numbers in, then I should see that this should be about 4 seconds. And in fact, it would be exactly 4 seconds. Okay, and how did we get there? Well, notice 19.6 is exactly twice 9.8, and I'm doubling that again. So if I divide 19.6 by 9.8, I get 2. And then another 2 here. Technically here I should get 2.00 with sig figs, and then 2.00 multiplied by this factor of 2 gives me 4 seconds. Now, what that also means is that it took 2 seconds for the object to reach its peak, and then 2 seconds for it to fall back down. Okay, but that is how we can find the total time of flight. And now, what about the maximum height? Okay, so what about the maximum height? Well, we were already given that this is equal to VI squared over 2G, and so this is going to be 19.6 meters per second quantity squared over 2 times 9.8 meters per second quantity squared. Or I'm sorry, meters per second squared, not quantity squared, but meters per second squared. Now, what is this? Okay, now a quick way to do this in your head without using a lot of calculation. We already know that 19.6 is twice 9.8, right? And I have 2 of them here. So what I'm going to do is write this out as 19.6 times 19.6. I'm going to bring the units out here. Okay. Now we know that 19.6 is twice 9.8. So if I divide one of these 19.6s by this 19.8, or by this 9.8, then I get a 2 here. Okay? But I have a 2 and a 2, so those 2's will divide, and I'll get 19.6. When my units are done canceling out, I'll be left with meters. So this is the maximum height, 19.6. So the object travels upward 19.6 meters, and it took 2 seconds to get there, and then it'll take another 2 seconds for the object to fall back down. All right, in the next video, we'll do a slightly more complicated example where we'll be given some of the actual height and flight time, and then we will actually have to find the gravity. So let's suppose we're on another planet, okay, and we actually have to find the gravitational acceleration on that planet, okay? So it'll require a little bit of algebra and a little bit of problem solving, but it's the same flavor, okay? Just a little bit different.